This is going straight into the F tier. Hi, today we're going to be ranking algorithms and data structures in the context of coding interviews. And so the goal of this video is to help you understand what's best to learn first and which algorithms and data structures have the best rate of return, meaning which one should I spend more time on to succeed in a coding interview and an online assessment, and which one should I spend less time on in order to maximize my rate of growth. Let's start off with backtracking. So the idea of backtracking is that we want to do a combinatorial search. And based on this combinatorial search, we don't want to go through every single possibility. If we see a possibility that, you know, doesn't work anymore, then what we're going to do is we're going to go back up our traversal tree or our combinatorial tree, and we're going to search from a new position onwards instead of continuously going on. And that's the idea of backtracking. So let's say, for example, we were to solve a Sudoku problem. In theory, we could go through every possible solution or every possible combination while we're trying to solve it. But how about this? We try an option, and if it doesn't work, then we take a step back and erase our answer. And the same thing idea, or the same kind of idea happens in a crossword puzzle or a Sudoku, or really any kind of like guessing. And with these guessings, if we see that the guess is wrong, we can take a step back and we can solve from there. So this is a pretty important topic, but I don't see it too often inside of a combinatorial search. So what I'm going to do is I'm going to put this in the B tier for backtracking. Now on to the next. So let's talk about BFS. BFS is an algorithm or a general graph search algorithm where we go through every possible node or state in our graph. So what I mean by state is that we can have for example, a Sudoku puzzle. In a Sudoku puzzle, what we can have is the state, which is the current solved or the current numbers that we have on our Sudoku grid. Then once we go to another state, which is possibly adding or removing a number, that's called traversal right there. Now, BFS is a special type of traversal where we're going by layer. So instead of DFS, where we're going all the way down, we're doing a layer by layer approach and then working through every single possible layer. So for example, in the Sudoku setting, what we would be doing is we would write every number or we would try every number in every possible grid or in every possible cell. Then from each of those, we're going to write the second number, and so on and so forth. So this is a pretty important algorithm, and if you master BFS and DFS as well, then you can pretty much solve almost 50% of algorithm problems on LeetCode or in the coding interview. So I'm going to put this in the S tier. Now on to the next one. The next algorithm that we have is binary search. Binary search is a really important algorithm, and if you understand and master the advanced topics of them, then you can get pretty far. But for most people, they only understand the basics. So in terms of rate of return, if you understand binary search, and there's a lot of topics on binary search on AlgoMonster, and if you understand all of them, then you should be able to solve another slew of maybe 10% or 20% of the problems on LeetCode or any coding interview. Not only is binary search a really important topic, it's also an elementary topic. So if you don't already know it, you should definitely read it up on our AlgoMonster article. And yeah, so in terms of tiering, it's somewhere between an S and an A tier, but just because the frequency of binary search isn't as common, I'm going to put this in the A tier. The next algorithm that we have is DFS. So just like BFS, DFS is a graph or state traversal algorithm, and I would say that this is on par, if not better, than BFS. Now, although BFS can help you find the shortest path, or it might be more intuitive, DFS is actually an algorithm that can not only solve general recursion problems, but graph and combinatorial search, really. So that's the idea of DFS. If you have an unknown amount of levels that you need to go through, then DFS is your friend. So what I'm going to do is I'm going to actually, instead of putting it back here, I'm actually going to put it at the front of the S tier. The next algorithm that we have is a really awesome one, and this is Dijkstra's algorithm, and here's Edward Dijkstra right here in the flesh. Now, although Dijkstra is a really powerful algorithm in terms of competitive programming, this is going straight into the F tier. Now, you might be surprised right here. Why is this going into the F tier? I've done a few LeetCode problems with this, but ask yourself this: how many LeetCode problems have you actually done with Dijkstra's algorithm? And was it just a shortest path algorithm or a problem like that? Have you really used it to the full extent in any coding interview or any LeetCode problems? And your answer is probably no, right? So that's the reason we're going to put it in F tier, even though the algorithm is super useful in competitive programming or even in general real life. In terms of coding interviews, they rarely ask this. So Dijkstra's and in general, a shortest path algorithm is going to go in F tier. Now, that isn't to say, once again, that the algorithm, you shouldn't spend any time on it. We're just saying that the rate of return is pretty low. Of course, you want to read up on it, you want to learn about Dijkstra's or Floyd Warshall's algorithm and all these different shortest path algorithms, but in general, if you just know how to implement it, they're not going to ask you anything crazier about it. The next thing that we have is divide and conquer. Divide and conquer is a pretty special algorithm. One of the most common divide and conquer algorithms is probably merge sort, where you're splitting the list in half and then solving those lists and then keep splitting in half and keep splitting in half until you solve the entire array. Where solving it basically means sorting it. Now, this is a pretty common algorithm, merge sort, but realistically, when have you really implemented a divide and conquer algorithm, or when did an interview tell you implement merge sort? Merge sort, really. You might want to read up on it once and think about the idea, but really, divide and conquer is less important than backtracking, I would say, but more important than Dijkstra's algorithm. So it's somewhere between C, D, and E. So I think I'm going to put this honestly in the D tier for divide and conquer. The next one that we have is the dynamic programming algorithm, or the idea of dynamic programming. It's not really an algorithm, it's more of like a way of thinking, but I would say that dynamic programming, so the idea of dynamic programming, if you don't know, is we're trying to save the state and use the previously computed states to compute the current state. So for example, like the Fibonacci sequence, it's actually a pretty bad example to introduce dynamic programming using Fibonacci, but let's stick with it. So the idea really here is that we want to, solve fib n, which is the nth Fibonacci number. How do we do that? Well, we can use it, or we can solve it by using Fibonacci n minus 1 plus Fibonacci n minus 2. But those also branch out again. And fib of n minus 1 depends on fib of n minus 2 and fib of n minus 3. But we already need to compute n minus 2, so why are we doing it again if we're already doing it on the right side? So the idea here is actually to store these answers and use them when we actually need to use them again. So the idea of dynamic programming is basically just recursion, but storing the results so we don't have to do any recomputing. So dynamic programming, it's a pretty important topic, but realistically, if you know DFS, you just add memoization to it. So I wouldn't say it's that important. So I'm actually going to put this in the C tier, which is pretty controversial. But once again, you can implement a DFS with memoization, and you can just call that dynamic programming, really. As long as you can understand that there are repeating states, then you can pretty much just add memoization to your DFS, and there we go, we have dynamic programming. And also, if you wanted to do it iteratively, it's really not that hard. Just keep the transition the same. So how do you compute from fib of n to n minus 1, n minus 2? You pretty much keep that the same and just write a loop for it to go through every possible state. And that's dynamic programming, so I think C tier is pretty justified. The next algorithm, or actually data structure in this case, is actually the disjoint union set. So disjoint set union, or DSU, is a pretty famous algorithm for connecting different nodes and checking whether or not there's a connection between any of them in O of alpha n time. So the idea here, or actually you can even do it in O of 1 time, really, based on coordinate compression. So the idea of, or not coordinate, sorry, path compression. The idea here is that we have a bunch of sets and we can connect them by using a kind of parent array. So finding the connectivity between two nodes is really easy in this, but I would say that it's kind of in the same class of almost dynamic programming and divide and conquer. You'll rarely get to use this, but when you do, it's really useful. And I would say you want to spend a decent amount of time just learning the algorithm and practicing a few questions with it. So I'm going to put this in it's either going to be C, it's, I'm going to put it in the C tier. There we go. And it's definitely behind dynamic programming just because once you understand how DSU works, you don't need to, you just do a few practice problems here and there, and you'll be able to master it fully for the coding interview. Whereas dynamic programming, you need to solve a lot of problems in order to understand and get that feeling of dynamic programming. So I think C tier is pretty justified. The next algorithm or way of thinking is the greedy algorithm. So greedy is a pretty niche topic, I would say. There's a few times where you can pretty much just guess that it's greedy, or otherwise you can pretty much just do dynamic programming and see if that works. But the idea of greedy is you'll always be given a problem where you want to either minimize or maximize something. And if you're given that keyword, you want to think either dynamic programming or greedy. So greedy doesn't really come up that often because it's hard to prove during an interview, and the interviews know about the proofs, but they don't really want to see you doing it. So I would say that greedy, the amount of time you want to spend on it is somewhere in the F tier, honestly. It's either between E or F, just because you don't want to spend too much time thinking about improving all these greedy algorithms. So it's down there, definitely. The next algorithm, or actually data structure that we have, is a hash map or a hash set. So a hash map or hash set is a kind of data structure where we can associate a key and a pair together, and we can look up the value based on a key in O of one time. And additionally, for a set, we can check whether or not a number already exists in our set in O of one time as well. So this is actually a really common interview question data structure. For example, the two-sum problem actually uses a hash map in its solution. So what we're going to do is I'm going to say this is an S tier data structure just because it's so common, and the rate of return for learning about hash maps and hash sets is just really high. The next data structure that we have is a heap, or as many of you know it as a minimum heap or priority queue or something along those lines, a min heap, a max heap, priority queue, etc. So the idea here is that if we want to be able to find the minimum dynamically or the maximum dynamically, we can put that all in a heap, which could be done in n log n time. So that's pretty useful. And if we only want to find the first k smallest elements, for example, dynamically, then we could also use a heap in n log k time instead, where we only keep k elements in our heap. So this is actually a pretty useful algorithm, but really the number of times that you're going to be seeing this is not too often. It's more of like a optimization. And this is something you want to more so practice instead of just reviewing it. So it's definitely not F or E. I think I'm going to put it in the D tier. The next algorithm that we have is the line sweep algorithm. Now, the line sweep algorithm is the idea that you don't want to go through, for example, a billion points, right? Instead, why don't we only care about the points where there's actually something happening there? And these things where things are happening there are called events. And so we only traverse through the events in all of our array. And what we want to do is sort them beforehand in order to make sure that we're going through them in order. And so I would say this is an E tier algorithm. The next data structure that we have is the linked list. Now, the linked list is a pretty common algorithm for data structure, for coding interviews in general. So I would say that linked list is something that you really want to practice a lot. There's a few different tricks as well. For example, if you wanted to check whether or not what is the repeating digit in a list of 1 to n numbers, and one of them is repeating. Now, obviously, you could use a hash map to check the frequency of all these numbers, but actually, there's something called Floyd-Warshall's tortoise and hare algorithm, and these are one of these little tricky algorithms that you want to learn for linked lists in order to solve your coding interview problems. So In general, they're asked pretty often. So what I'm going to do is I'm going to put this in the A tier. And that's just because the rate of return is just so massive that if you spend the time learning it, you might pass 20% of LeetCode questions or AlgoMonster questions already. So that's pretty good. The next data structure that we have is the monotonic stack and queue. So the idea of the monotonic stack and queue is it's really useful for when you want to dynamically look for something, and that specific something is the first value that's greater than the current value or the first value that's less than the current value. And so it's actually pretty important to learn about this algorithm, but this is for more so advanced interviews. So if they really ask you about monotonic stack or queue questions, then you definitely know you're up there. So you want to practice this a few times, but really the rate of return for these monotonic stack or queue questions isn't too high because they aren't asked all that often. So recently, coding interviews have become a little easier in the sense that they're not going to ask you these crazy questions anymore, and they're more so interested in your communication. So I think I'm going to put this in C tier just because there isn't too much demand for harder question nowadays. So I think a C tier would definitely fit here. The next algorithm that we, or actually data structure, is the minimum spanning tree. I would actually say this is also more so a algorithm and data structure combination, just because you can use both at the same time. You don't have to really store the tree actually. So I haven't really seen MSTs all that often in coding interviews or OAs in general. So I'd say the rate of return for using them or learning about them in general is pretty low. So I'm going to put this actually in the somewhere between E and D. I think I'm going to put them in the D tier just because it's still kind of useful to learn Kruskal's or Prim's algorithm, but it's kind of not that useful in terms of coding interviews. Next, we have the segment tree data structure, and this is a pretty famous data structure in terms of competitive programming, just because it's able to give you so many different queries in logarithmic time. And you can even do point update and range updates, range queries and point queries, all in logarithmic time, which is really impressive actually. And such an algorithm, or such a data structure exists solely really for research and competitive programming purposes. You really won't see this during any interview. And if you were to be asked a range sum kind of question, I would say just use a prefix sum array, really. And if they bring up that you can do updates as well, just tell them about segment trees and just move on with your life, really. Because you're not going to be able to code up a whole segment tree during an interview, especially without failing at a smallest part. The segment tree is really hard to, or it's really easy to mess up, sorry. So you want to not spend too much time on this. So I'm going to put this in the E tier. The second last data structure that we have is the trie. Now, the trie is basically also called a prefix tree, where we basically create a prefix of some words, and this way we're able to find whether or not a word exists in our dictionary really quickly. Now, of course, we could use a hash map or something like that, but what if I had more complicated queries? What if I wanted to do some kind of autocomplete, right? I wanted to check whether or not this prefix of a word or a word exists based on a prefix. If I have, the word hello in my trie and I typed in HE, I want to see whether or not which words exist with the prefix HE. So this is called the prefix tree or trie. It's a pretty useful algorithm to learn, and I'm going to put this in the C or B tier, really. I think in the C tier just because the rate of return is still kind of medium. I would say it's kind of 50-50 on the return. Not too many interviewers are going to ask you this, but it's still going to be asked. The last algorithm that we have is the two pointers algorithm. The two pointers algorithm is a really useful algorithm just because it can optimize a lot of O of n squared algorithms into O of n just by noticing a few little caveats in your loop condition. So one thing that you want to do when you're focusing on two pointers is think about the loop invariant. What are the pointers always pointing at? Are they pointing at the correct location at the current time? So you want to think about these different things. So when you're solving two pointers, you want to solve a lot of these problems and get a good sense of what's happening. Now, in terms of ranking, the rate of return is actually really high for two pointers. You will see these a lot in coding interviews. So I'm going to put this in the A tier, and that pretty much says it all for two pointers. All right, so that's pretty much it for the algorithm tier list. If you have any, complaints or suggestions on where you want to put a specific algorithm or any algorithms that we missed, feel free to leave them in the comments below. And if you think our list is controversial, also let us know in the comments below. And finally, if you're interested in learning about these different algorithms, check out algo.monster or algomonster website, where you can learn more about these algorithms and the frequency at each company like Google, Microsoft, and Facebook.